Okay, let's do problem 649 Dota2 SNET. Not sure why they said Dota2, it's quite irrelevant. But the whole point is there are lots of SNETs from two different parties, and then we determine who wins. So in the string, we have RD, like a mixture of R and D, each representing a different party, and then what they do is they're gonna vote in the order they appear in the string. So R votes first, and then, but the way they vote is quite strange because they basically vote to make the opponent to lose the right to vote. So R votes so that D loses the right to vote, so he can't vote permanently, and then they do another round, and then R finds out that there's only senators from one party, and then they can announce the victory. Likewise here, R makes D to lose the vote, right? And then when it comes to this D, he can't do anything, and then when it comes to D, he can make the R to lose the right to vote. And then we do another round, and then R can't do anything, D can't do anything, and then this D finds out that there are only senators from Dyer who can vote, so he announces victory. It's not necessarily only one senator from each party, it can be multiple. All right, so this question we're going to use 2Q, one for each party. So Q, and I'm gonna put integer, and then I'm gonna call it RQ new linked list, and Q integer DQ new linked list, and then we're gonna have index. So basically we're going to iterate through each of the character, which is each of the party in the string, and then populate the queue with the indices they appear. So for car C in senet to car array, if C is equal to R, rq.add index, and then we're gonna increment it. Else we do dq.add index plus plus. All right, so far R has index. So if I look at example 2, R has index of 0, and then D has index of 1 and 2. What we're going to do is we're going to loop around until both of the any of the queues is empty. So while rq dot peak is not null, and or it can be end, and dq.pick is not null. So if any of them is null, we break it. And what we do is if rq.pull is smaller than dq.pull, so we pulled this 0 and 1. So rq is smaller, so this guy bent this guy here. Then means we do rq.add index plus plus. So basically this guy survived, this guy died, and then we added 3. Now we do another comparison. So else dq.add index plus plus. So compare these two. D is smaller. We pulled both of them and then we added 4. So now the while loop breaks, and then we can return RQ is empty. In that case, RQ is empty means D1, so radiant, else dire. Let's run the test. Wrong answer. What's going on? If RQ is empty, that means it's dire than 1. Okay, let's submit. All right. But actually, there's a very interesting method. It doesn't involve any of the queue. It actually uses the concept of credit ban or ban credit. So string builder, it only needs string builder. And they initially puts net here, and the int ban credit. So they assume that positive ban credit means R is winning, and then negative credit is essentially positive credit for D, but D is winning. So what we're going to do is we're going to iterate through the string builder. So for int I equals 0, I is less than sp.length, and then I plus plus. So we are going to get char c is equal to sp.char at I. And then obviously there will be 2 scenarios where c is equal to r, and then c is equal to d. So we said when it's positive credit, when it's positive, R is winning. But we actually check if the ban credit is negative. In that case, R is losing, so we have to apply the credit. So sp.append d, else, and then we do, because they use the credit, so we can do ban credit plus plus. Else, if ban credit is greater than 0, then sp.append r, and then ban credit minus minus. Suppose we have string of r. What's going to happen? So it's going to look at r, and then the ban credit is not less than 0, so we just add the ban credit. So ban credit will be positive. So that's it, R1. So we just return ban credit is greater than 0, radiant, else, dire. Now let's have R and D. R, we have ban credit is now less than 0, ban credit is now 1. Now in the next iteration, we are at D, so ban credit is greater than 0, so we append R. And then ban credit goes down. And then the next one will be ban credit is it's not less than 0, so we increase the ban credit to 1. That's the end of the for loop. Now R1, so we're returning the value. So let's run the test. So now it's 10 milliseconds. And let's submit. Okay, now it's 5 milliseconds. So it's quite a significant change. It's a difficult concept, but it's quite useful.